the cycle of annihilation and creation starts again as the buildup of heat beneath the surface of the Earth tears Rodinia apart. When Rodinia splits, it forms several smaller continents that for millions of years drift apart and then drift back together again to form Gondwana, a supercontinent in the southern hemisphere. Eventually, after several 100 million years, Gondwana slowly splits apart. Plate tectonics pushed the land back together to create the world's last supercontinent. It's a huge landmass known as Pangaea. All the continents we know today are here, joined together. Geologists are able to plot the continents' relative positions because 350 million years ago, there are numerous species on Earth, each living in distinct regions.
This specimen that I have right here is the first trilobite that was ever described from what is now the United States. It is exactly the same type of trilobite that occurs on the other side of the Atlantic Ocean in North Africa. So we know then that the trilobites in the old and new worlds must have been close together because they're so closely related.
The fossil records show that North America and Europe rest next to one another. The land where New York now sits is next to Morocco in North Africa. The Atlantic Ocean does not exist. The east coast of South America nestles against the western coast of Africa, while Australia, India, and Antarctica are joined to the southeast of Africa.
If we want to look at a picture of the world 250 million years ago, we're going to look at a world in which a four-footed creature could walk from one end of this landmass to the other.
Pangaea is one giant continuous landmass. It not only makes the world look very different, it also has a dramatic effect on climate. Because much of the land is located far from the sea, the climate of the interior changes radically from season to season. It gets very hot in the summertime and extremely cold in the winter.
You don't have the moderating influence of the ocean that we have today. So it's a very different world. And it's a world that in some ways is harsher and less hospitable, at least to life on land.
It's thought that the climate change caused by Pangaea's formation may have played a role in one of the largest mass extinctions on Earth. This event, known as the Permo-Triassic mass extinction, wipes out about 90% of all life on Earth.
It's been called the mother of all mass extinctions. I would consider that the formation of Pangaea, with its climate worsening effects, to be a contributing factor, however, and not the sole cause of the mass extinction.
250 million years ago, and the supercontinent of Pangaea is breaking up. The continents we know and recognize today begin to take shape. Over the next tens of millions of years, South America drifts away from Africa, North America away from Europe. Australia splits off from Antarctica and heads north to warmer climes. The positions of our continents are becoming familiar, although their distinguishable features are not. The world's vast mountain ranges, the Alps and Himalayas, and its great valleys, like the Grand Canyon, are yet to form. They will emerge out of one of the biggest battles in nature, the battle between colliding continents. Earth, 100 million years ago. The continental map of the modern world is gradually becoming recognizable. But a battle is still raging between the continents that will change the face of our world forever and create some of the most extraordinary geological features on the planet. As the continents move slowly across the Earth, crust and rock is dragged back down into the Earth at subduction zones between the tectonic plates. But when continents collide at the plate junctions, Sometimes there is a battle for supremacy. If neither plate will submit and drop down to be consumed by the mantle, then both the continents slowly smash and grind into each other. These pinch points of continental collision build mountains. The Alps are the largest mountain range in Europe. Higher than the Rockies, the Alps stretch from France in the west through Italy, Switzerland, and Austria to Slovenia in the east. Their formation is a direct result of a continental collision between Africa and Europe. The story of the Alps begins when the African plate breaks away from the South American plate. It starts moving toward Europe.
Without the plate movement, there wouldn't be any mountain on this planet.
Professor Gerard Stamfli of Lausanne University in Switzerland studies the processes that built the Alps. The African and Eurasian plates start to move toward each other, trapping a third, smaller Iberian plate between them. The three plates collide. The Eurasian plate is pushed downward into the mantle, chopping off the Iberian plate. The Tethys Sea begins to close. As the Eurasian plate grinds underneath the African plate, it pushes the Tethys Sea floor and part of the Iberian plate 600 miles north and many thousands of feet into the air. Rocks that started life on the bottom of the ocean end up at the top of the Alps.
Quite fascinating to imagine that if you are on top of the Matterhorn, you're actually staying on top of Africa. For geologists, Africa stops in the Alps.
Over the next 100 million years, the continents continue to smash together. New mountain ranges start forming around the globe. The largest, the Himalayas, form as the Indian plate charges northward toward the Eurasian plate. It moves at 2 inches per year, lining up a head-on collision. The movement of the Indian plate leads to a clash between two giant continents and creates some of the highest structures ever to exist on Earth. The incredible power of continental drift not only builds mountains, it also sculpts one of the world's most recognizable landmarks, the Grand Canyon in Arizona.
The Grand Canyon is a great scar on the surface of the Earth.
Geologist Ron Blakey has been studying the canyon for over 30 years.
It's just a wonderful place to come face to face with planet Earth.
The Grand Canyon is 277 miles long and up to 18 miles wide. At its deepest, it stretches down for over a mile. The gorge exposes the interior of the North American continent. It's like looking through the pages of a book. Each layer tells a story about the past.
One of the really neat things about Grand Canyon is as we go up the walls of the Grand Canyon, it's just like going through a time machine.
Layer upon layer of rock reveal the geological history of North America, from present day to 2 billion years ago. The deeper you go, the older the rocks. By studying the layers, Blakey can piece together the history of the canyon. He finds some of the most interesting evidence at the very top: fossils of ocean creatures.
Wow, this bed's the jackpot here. What we have is an extraordinary example of a Permian seafloor. The most important thing it tells us with respect to the Grand Canyon is that this area had to be near sea level when these rocks formed. Now it's 7,000 feet above sea level on the rim of the Grand Canyon. So something had to happen. Either the sea had to fall 7,000 feet, and we're pretty sure that didn't happen, or this landscape had to be uplifted 7,000 feet. We're pretty sure that happened.
250 million years ago, the canyon starts to form as a result of a collision between the Pacific and North American plates. They collide with such force, the North American plate thrusts more than 2 miles upward. What was once seabed rises over a period of 15 million years to form a vast plateau far above sea level. It stays that way for millions of years until it is transformed by water erosion. Six million years ago, several hundred miles south of the canyon, plate movements open up the Gulf of California to the sea. For the first time, small streams in the Rocky Mountains could empty into the ocean.
So if we're starting a stream at 14,000 feet in the Rocky Mountains and carving down to sea level, and the Grand Canyon just happens to be in the way, the Grand Canyon's going to get cut out.
These streams merge to form what is now called the Colorado River. It cuts down through the land, heading toward the Gulf of California.
It took a river to carve the canyon. The water has carved down through the rocks layer by layer by layer, removing material out of the canyon and leaving the great void that sits behind me.
The Grand Canyon is a testament to the awesome power of the continents in shaping our world. Back on our journey, tracing the birth and death of the continents, it is now 20 million years ago. 2,500 miles south of the Grand Canyon, another plate collision is about to take place.